If you look at your trigonometry handout, this is the second one. The first page is asking you to label the sides of the following right triangles. You'll also notice that the angle you're supposed to relate it to isn't there, so you're going to have to pick an angle and label it accordingly. So you can do that. And then we turn to the second page, and we have right at the top of the page it says SOHCAHTOA, and this is the example we're going to do. Before I get to this, we have to talk about what is this SOHCAHTOA. SOHCAHTOA. Well, this is how we remember how each trig ratio relates to the sides of the triangle. So the three trig ratios we're going to talk about are sine, cosine, and tangent. Those are the three that we are going to use this year. So sine compares the opposite side to the hypotenuse. So sine, and it's always sine of an angle, so sine theta equals opposite over hypotenuse. And you've noticed that I shortened these, that's fairly common. Okay, so sine equals opposite over hypotenuse. The cosine, or cos theta, is equal to the adjacent over hypotenuse. And tan theta, tan of an angle, is equal to the opposite over the hypotenuse. Oh, pardon me, opposite over the adjacent. Oh, shame on me. Opposite over the adjacent. Okay, so tan is opposite over adjacent. Cosine is adjacent over hypotenuse, and sine is opposite over hypotenuse. So those are the three angles that we're going to talk about. Or sorry, the three ratios we're going to talk about. So another way you might see this at some point, I'll probably draw them for you. You've got sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And we'll talk in a bit how we can use these triangles to when we're doing this. But let's look at how to solve this triangle. So here we've got x, we've got an angle, and we've got this. So this is the angle. So this is our theta right here. Okay, our 47 degrees. Well, if this is our right angle, that means this is the hypotenuse here. And this would be the adjacent side. So this is the opposite side. So if I have the opposite and the hypotenuse, well, opposite and hypotenuse, I'm talking about sine, or over here, sine. So sine theta equals opposite over hypotenuse. Okay, I know my angle, so sine of 47 degrees. Make sure you write the degrees in. It's not something we deal with this year, but there's actually two ways to measure angles, and we need to use degrees if that's what we're talking about. Is equal to the opposite. Well, the opposite I don't know, and over hypotenuse is 3.8. Okay. Now algebra tells me that I want to isolate x, so I've got to multiply both sides by 3.8. So x is going to equal 3.8 times sine of 47 degrees. And I can just multiply that. You put that into your calculator. Now, here it's going to be very important to learn how to use your calculator. Some calculators you need to put in the 47 first and then hit sine. Other ones you're going to put in sine and it's going to show up as sine open bracket, and then you put the 47 in. Also, it's very, very important. Make sure your calculator is in degrees. You have to see somewhere it'll see a little DEG. Okay, that means your calculator is in degrees. If it's in radians, RAD, in your TI, you have to scroll down under mode. And if you're not sure, just come talk to me and I'll show you how to do that. If you are in radians, you're going to get totally wrong answers. So put into your calculator 3.8 times either sine 47 or 47, then you'll hit sine, and then you'll multiply that by 3.8. Either way, you should get an answer of 2.8. And in this case, we're talking about meters. Okay, make sure if they're given units that you have your answer in units. So this is your answer right here. If you did not get 2.8 on your calculator, you need to check, first of all, to make sure you're in degrees and not radians. And secondly, to make sure that you are inputting it properly with the with your sine function. So these are things you're going to have to learn how your calculator works to make it work. Now, what about these triangles? What are they telling me here? Well, here I was looking for the opposite. So what you can do is you can cover up. I can't really show you how to do it here, but you cover up the opposite and you can see that you need to multiply the sine of the angle by the hypotenuse. Let's say we were looking for the hypotenuse and we had the opposite and the angle. You cover up the hypotenuse, you're going to have to divide the opposite by the sine of the angle, and you'll see examples of that. That's how you do the sine of the angle.